introduction. Okay, so as we mentioned last week, we're going to continue for the whole chapter 4 and no, for the whole chapter 3 as preparation for your midterm test. Okay. Um, okay, where were we last week? We have learned about the estimation basically. Okay. We have learned how to determine a point of estimation, how you determine the interval of estimation based on your confidence level, based on your significant level, the value of alpha. And we have seen the two types of sampling distribution in a way for us to estimate the population for the population mean and also for the population proportion. So these are the two things that we have learned so far up to last week. Okay, and yesterday we managed to have our first physical class together with section 1. We will see how it goes, whether we want to keep that small numbers that it allowed to attend the room for the room, or maybe we can request a bigger room for the upcoming week lah, to see how it goes. So for today, we're going to continue under this chapter, estimation and hypothesis testing. We are going to see first, we're going to understand first the reason, the idea, the procedure on how we are going to do this hypothesis testing. Okay, and we were going to start with one population first. Okay, the reason of one population, we understand well first that one population cases is before we expand it into different population of data. Okay, if we try to expand the number of population. Okay. So I love to repeat this part again. The intention here after we learn this topic, okay, hoping that everyone is so much clear on the general concept of the hypothesis testing, and then you are also able to identify what are the correct procedure or test when you are dealing with when you are dealing with a population mean and population proportion. Because by now, I'm hoping that by this week, everyone actually clear the difference between sampling mean and also sampling proportion. There are two types of things, and wherever it is very important, we also clear what kind of procedure to differentiate between these two means and proportion. Okay, and then and after we understand the concept, able to know what kind of test and procedure to apply, later if you are more confident, to apply this hypothesis testing in any decision making. Okay, in decision making of what? When you have a data, you want to do a reporting of the data, you have to do the analysis part. So the analysis is the one that one of the analysis that you can do is by doing the hypothesis testing. So this is the general overview first about what to expected for this subtopic. Okay. So basically, some of the concept, definition of the concept has been stated here. Okay, we have some claim or some theory. Okay, and then we are try to estimate the population based on the sample that we have, based on the sample of data that we have, and then we are try to make the decision whether our claim or our theory is actually is the one that whether the sample data is actually agree with the claim that we made earlier, or we need to provide more evidence to support our claim earlier. So we are going to see this step by step in this hypothesis testing. So that is why it's called hypothesis testing. Okay, and then the purpose of hypothesis to find out whether if a given claim or statement about the population is true by using some sample information. So this is the appropriate sentence lah on what is the purpose of we doing hypothesis testing. Okay, so it all come back to understand the estimation population. Okay, where we know that there are certain tests depends on the sample size and also depends on whether your variant is known or unknown. Okay, maybe just some maybe just recap on this estimation part. If we go to this as I mentioned to you guys earlier, this table is a very important table that try to summarize everything. Okay, for us to determine which test that we should rely on depends on number of sample, whether we are doing whether we have a large number of sample or small sample size. Okay, and at the same time, are the variance is given or known, okay, or is actually unknown. Okay, clearly the Z, yes, this Z is actually your critical value, okay, that to determine whether you are going to refer to the Z test, whether you are going to do the Z test or the T test. Because the Z test meaning you are referring to normal distribution table, okay, where the T test you are referring to the distribution table. So I'm hoping that along the way, maybe some of you can write down all the important notes, okay, in the chat box as well to help your other friends. Okay, we have done this one. We will continue to have the testing, and then I really really hope you guys by now everyone is actually already familiar with the notation. Even I keep repeating this part over and over again. I'm hoping that it's already stuck in your mind the how we use the notation to represent a sample of sample mean or sample proportion, standard deviation of sample, variance of sample, to differentiate with the sample of mean of population, variance of population, and first standard deviation of population. So we will keep using this. Okay, so by now, as an overview of hypothesis testing, okay, you can see here, okay, this is just maybe summarized. It's a bit, maybe it's a bit tedious. Let's move to from the left to describe. Okay, so we have the mean large. Okay, here we have the mean large, where we use the hypothesis testing uh, for the population mean for a large number of sample. Okay, if you want to say what is large here, so here meaning that we the hypothesis, this side is the population testing. Sorry, this side on the left side is the hypothesis testing for a sampling mean. Okay, for a large sample size and also for small sample size. Okay, so these two blocks, these 2 points here is to differentiate. We have a we are doing a hypothesis testing for sampling mean. Okay, one with a large sample size and one is actually for small sample size. Okay, moving to this way, okay, we also have a proportion, okay, proportion value, proportion sampling, that where we can also apply the hypothesis testing. Okay, and one more is actually we are referring to the p-value. This is also valid for the mean and proportion. So by right, overview of the hypothesis is involved this kind of sampling that is required before we come out with the conclusion on to support our hypothesis that we made earlier. Okay. So first thing first, let's go into what is the hypothesis statement. But to do that, maybe we go for a sampling mean first with a large number of size. Okay. So first, okay, there are a few things that we have in this table. They try to summarize, okay, in any claim that we want to make or we are going to test, okay, how we transform that into a mathematical expression or notation, especially to it is called a hypothesis statement, okay, is shown in this right table, on the right table here. Okay. Okay, if we go line by line, okay, so in the first row here, okay, it stated that we are going to do some test or we have some claim that mean of certain okay, maybe anyone can give one example of mean of statistic analysis that you plan to do for your survey data for the group assignment. Any idea? Maybe we start with one. Okay, mean of okay, on average, the height of a student for BEKM, okay, is greater than 140 cm. Okay, that is the claim that we probably want to do. Okay, so how to write that into the how to rewrite that in the null or alternate hypothesis is by writing that, okay, the claim is state that the average height of a student is greater than 140. Okay, so meaning that I have, if I write in the form of notation, I will say that the mean, this is notation for mean, is for the null, because here the H naught with the subscript 0 there is to refer to the null hypothesis, and H1, okay, H1 there is to refer to the alternate of that. Okay, as you can see, if I say if that is the statement that I said earlier, okay, the average mean of a student of 2 BKM is greater than 140. So that is actually my claim. So my claim is actually in the alternate hypothesis part, because I'm using the word greater than. Okay, so greater than, so meaning that the mean is greater than 140, 140. Okay, and the null hypothesis is stated mean equal to 140. Maybe I should write. Okay. So that is one of the examples. Okay, so if I say I want to make a test, or I have some certain claim that the mean average mean of a student here is 140. So meaning that my H null will be the mean 140. Okay, and my alternate, because I said greater than, so the mean is actually 140 here. So this is actually my claim, the position of the claim that we're going to test later. Okay, so these are the first step first. To based on your claim or whatever test that you're going to do, you have to transform. Okay, you have to rewrite the hypothesis statement, which is actually the notation is referred by H null and H1. Okay, okay. So this is one example. Okay, maybe you have a different kind of test. Whether you want to test maybe the average of weight of student, or I couldn't find any good example here. Maybe you want to test the average the average the the average the average amount of money spent per week for the student nowadays is less than 10 ringgit, for example. Okay, so the claim now is actually less than 10. Okay, that will be one of the very others. Yes, do you have any suggestion for the test? You can unmute your mic if your internet is good, or you can write in the chat box any average full up movement per week. Liza ni siapa? Okay. Tak, you have to, what are the tests that you want? If that will be your test, okay. If that is uh the test that are you going to say that at most average uh average apa? Bagilah saya. Average what at most per week? Average mean push up ke apa tu? That you think at most or at least. Okay. Boleh bagi contoh lain kat situ. I couldn't think of any lah currently. But we will see different form of hypothesis statement. But what is this table try to summarize here is, okay, you have to pinpoint to the keyword. Okay, obviously first you have to know, okay, this is for the mean, okay, for the population mean. So mean meaning that your hypothesis statement, okay, must involve mean. Mean. Okay, and this mean not is the value that you are doing the test. Okay, it can be 140, it can be 10, it can be in the unit of uh RM, in a unit of dollar, in a unit of kg, height, SEM, okay, and so on. Okay, so this is just the value. But when you are doing the hypothesis testing about the population mean, meaning that your hypothesis statement must state the mean equal to what, and or whether you are actually doing the greater than, smaller than test, less than test. So it's actually the difference is here. Okay, if you are focused on greater than, you see the claim is here. If smaller than, you use this form. If you actually uh, doing a test on certain average is different from or not equal, so you will see that your claim is in the alternate hypothesis, okay, where the sign of your mean is not equal to that value. Okay, in some cases maybe they didn't say about greater than, smaller than, or different or not equal. Okay, but it will say something uh the average of the average of daily cases of COVID recover from COVID is at most uh 10,000 a day, for example. So when it's at most, that the claim now is actually at the H null, okay, and the value of H alternate is greater than. It's actually similar, have a similar hypothesis statement like this one, okay. But the position of the claim is different now, okay. Can you see the difference, guys? So this table is trying to summarize different tests. They will come out with different notation of a hypothesis statement. Okay, but the position of the claim also will be different, and that is where we're going to uh that is where we're going to see the step by step. Your thought, Razak, Abdul Razak? Yang berbunyi tak? Dalam apa tu? Bangun tidur ke? Dalam sahur ke apa? Okay. So on the other on the different test or claim, you will also see that when you are going to test for mean at least, meaning that to say that maybe you're going to say that on average, people that on average, the numbers of people that recover from COVID is at least 10K, 10K a day, okay, or a week. Maybe it can be 50,000 people a week. So when at least the claim is actually at the null, okay, at the null hypothesis, okay, and they have a similar form like when you have average or smaller. Okay, so pay attention with the way this table is construct, okay, because it will help you to get to understand, okay, what kind of claim that you made earlier, okay, what are the hypothesis statements that you will need to construct, where the claim, the position of the claim really are, okay, and then it will help you to establish the structure uh, of your hypothesis testing. Okay. Moving forward, okay, this table clear, guys? I think we have settled this part sebelum ni kan. Those who actually have class, you guys are welcome to watch the recorded version, and then once you finish the record, just tell me, then we can add the attendance. We can mark your attendance. I think not only you, Fatin, ada two other boys actually have the same thing, because we don't have we have to restructure balik timetable. Okay, okay. No, okay, so for this one, clear, guys, the table. Okay, so I will hold first on the on the part of decision of hypothesis testing, because I'm going to okay, I'm going to go for this one first. Okay, test statistic. Okay, so previously we know that test statistic is part of things that where we have a sample, we work on the sample, we try to calculate the value based on the sample that we have. Okay, and then we will make the value from the test statistic based on the sample that we have will help us to make a decision. So this decision is the one that regarding your null hypothesis now. Okay, what is null hypothesis just now? The one with H and H null earlier. Okay, so some cases the claim is actually at H null. Some cases the claim is at the H alternate. Okay, so for the H null, we are going to use this value from the test statistic to help us to make a decision. Okay, one thing that we learned last week is about the rejection region and also the critical value region. Okay, um, we will probably we can use the idea from the previous topic, okay, where we know that in some cases, okay, we have to rely to the value of alpha over 2, okay, which is the critical value, okay, that actually will separate between the region that is under the significant level, okay, we belong to the significant level region, or actually the part where we reject the region because of it's actually outside from the significant level. Okay, so this critical value is basically the cut off value, the separator between the boundary that we reject our null or we accept our null. Okay, what is the null hypothesis that to support our claim earlier. Okay, and basically this is we call this range of the value whether we are going to reject the hypothesis of this one as the rejection region. Okay, so having said that, macam okay, okay, how to make it easier? Okay, maybe we say we are 95% confidence level. We have that we will score A for this course, for example. Meaning that you still allow 5% error in your decision, okay, in your claim, okay. If you didn't work hard enough or maybe you didn't do any tutorial, so that will lead to your first claim. If your first claim is you said that I am 95% confidence that I will score A for this course. Okay, but along the way there's a process. There are so many samples involved along the way to prove to support your claim. Okay, so if you did it well and everything goes on, okay, your claim probably true and it's fall into this 95% area, for example. Okay, 95% region. Okay, but at the same time you still allow certain error, okay, maximum error here, to indicate that there's a things maybe not enough evidence to support your initial claim, or maybe there's some error happen in between, there's some weakness happen between your testing, okay, between your test statistics, okay, that leads you don't have enough evidence to support your initial claim earlier. Okay, so when I say this one, it actually come back to the whole process of hypothesis testing, guys. Okay, so please bear in mind there are I put it 4, but in some cases I will write in the 5 steps. Okay, there are 5 steps involved when you are doing this hypothesis testing. Okay, 1, 2, 3, 4, 5. I purposely put 5 here because one of the steps is actually you can split into 2 parts. Okay, so hypothesis testing is a method to test claim or your hypothesis about certain parameter population, okay, based on the sample. Okay, there are 5 steps here. Okay, I need your attention here on for this slide. Okay, so first step is you have to write, okay, you have to write the null hypothesis and the alternative hypothesis. Okay, so how to write this? This is where the part I showed in the table earlier. you have to pinpoint what is the claim, what is the statement of the claim, and then write whether the mean is greater or mean equal, less than or not equal for the alternate hypothesis. So this is try to summarize. Okay, the null hypothesis is actually the one that actually contains the most of the region that you accept, that you will support your null hypothesis. Meaning that is assumed, the population parameter is assumed to be true. So you put that in the null hypothesis region. Okay. Anything that actually you allow certain error to your claim, okay, you put that into at the alternative hypothesis. Okay. So the idea is actually a contradict statement from the null hypothesis. The null hypothesis is the one that you really confident with the because you have your sample, you make certain claim, okay, and you are confident with that. So you put most of the region portion into the null hypothesis, okay, and that but you still allow certain error to it, and then you put that in the alternative hypothesis statement. Okay, so the first step here, write the null and alternative hypothesis. Okay, the one that in the table, the previous table earlier. Okay, number two step here is you are doing the test statistic part. Okay, so the test statistic part is you work on, you calculate based on the sample that you get. Okay, the sample information that you get. Okay, this is the part where it will guide you whether you are uh, whether the value of your test statistic will fall into in align with your null hypothesis, okay, or is actually not aligned with null hypothesis, maybe it's actually the alternative hypothesis. Okay, that's the second step where you have your sample, you do the test. Okay, what is the meaning of test? Is the one that we did earlier in this table. Okay, based on number of sample and whether the variance is actually known or unknown. So these are the part of test statistic. Okay. Okay. So that's second step. Okay, the third step lah adalah you determine the value of critical value and whether this is the part where it actually can be the third and the fourth part actually. Okay, first you find the critical value and then you determine whether the value is actually in the rejection region or meaning that you have to do some checking lah. Check the value whether the critical value is actually corresponding to the significant level first. Okay, and the next step is actually from that value you determine the cut-off value whether you actually reject your null hypothesis. Okay, meaning that is actually in the rejection region, okay, or you accept it because the value from the sample, the test sample, is supporting your null hypothesis. Okay, and finally the last step, or because we split step number 3 into third and fourth, so the last step, the fifth step is actually based on that. Okay, after you reject or you accept your null, you make some statement or decision whether the first claim that you made earlier is aligned or not, or is it you accept the S null or you reject your H null. So that's the only two decisions that you make at the final step of hypothesis testing. Okay, maybe too much talking. We will use example. Okay, but in this example it's more structured first. Okay, so there are 4-5 steps. Okay, in a way to perform a test hypothesis. First, identify and state the null hypothesis and alternative hypothesis. Okay, we're going to refer to this one back. Okay, where you have to know what is the test that you make. Okay, and then what is the notation of your hypothesis, the null hypothesis. Okay, so these are the things that you're going to see, that you're going to write first in your hypothesis statement. Okay, I will put a hold for the population because it's actually similar, but the most important in the first step, you have to state the null hypothesis, alternative hypothesis based on the claim. Okay, the second one is you will select the distribution. So what is the distribution here? Is the idea here is you want to calculate the value of your test statistic. Okay, so what is the test statistic? As I mentioned, okay, it's actually come back to the number of sample size and also whether the variance is known or unknown. It depends back to this value, critical value, Z alpha over 2 or you are referring to the T alpha over 2. I'm hoping that you, this part, okay, you can watch the previous, the last week recorded session, okay, when we actually refer to the T test, when it's actually we refer to the normal distribution table. Yeah. So that one. So based on that, we do the test statistic. Okay, we put that on. Okay. I will focus now more on number 3, the step number 3, step number 3 and 4, where we are going to determine the critical value and whether we are actually reject or reject the hypothesis null or accept the hypothesis null depend on the location of your rejection region based on the critical value that you obtain in this step. Okay. But before that, let's come back again to this table. Okay, you can see that here in here. There are only 3 possible notation for the null hypothesis test. Okay, it's either you have the alternate hypothesis, okay, is actually greater than the value, okay, which is equal to this one, greater, or less than the value, or another notation is not equal to the value. Okay, clear this one? I hope you three is only these are the 3 possible way on stating your hypothesis statement. Okay, it won't be something. So from these 3 hypothesis statements, it will leads you to 3 different types of rejection region. We're going to review this together. Okay, I'm hoping that you get idea. But if you think you need more time for to understand it well, just let me know. Okay, so let's spend some time to really understand this how it works. Okay, just now we know there are 3 types on how you write your hypothesis statement. Okay, and we can split into 3 different types of graph here. Okay, as I mentioned, all the critical value is the value that separate the region where we accept the rationale and we reject the rationale. So that's why I just want you to go through the overview of these 3, the different about these 3. Okay, and then maybe write down a bit. Okay, I give you maybe 1 minute. Okay, to see the difference on these three figures. Just look at the difference of these 3 graphs. All of this is actually a graph of normal distribution. Okay, where the center actually at the average is actually similarity of these 3 graphs. The center is actually at 0. They have a similar, we can say that they have a variance of 1. Okay, normally distributed. The similarity is normally distributed. Average is at 0. Standard deviation maybe almost equal the same one. Okay. Now let's spot what is actually the difference between these three graphs. You can write some remarks at the chat box. Okay. I put this into 3 graphs lah. Number 1, number 2, and number 3. Okay. So you can always you can check the difference. Number 1 and number 2, and also the third figure. So we have 3 different figures, the normal distribution. Okay. The first and the second one is talking about the tail. Okay. And this one is one tail, and this one is about 2 tails. Okay. So this is actually applicable. Okay. Even though I put this testing mean, okay, this is also applicable for proportion. We're going to see what is actually the difference in notation of proportion later after this. But I just want to for now, we focus on the one population because we just have one, each of these figures, it just involve one single population data. Okay, one line only for the population of data of population. So figure 2 as well, 1, figure 3 also 1. Okay, the difference between these 3 is the shaded area. Okay, for the first figure, the shaded area is on the left. Okay, the second figure, the shaded area on the right. Okay, but for the third figure, there are two parts, okay, of the shaded area, one on the left, one on the right. Okay, did you see the difference, the common difference between these three? So we zoom in into each of this figure first. Okay, so what is this shaded area mean? Okay, this shaded area means that this is the region of rejection. Rejection of what? Rejection of the H null. Okay, so H null can be your claim. H null also can be the region where you where you hold to your claim. Okay, so there are there are certain region on the left, okay, on the right, and it can be a two-tailed region where the rejection is actually on the left side and the positive side. Okay, so let's move to the first one, left tail test. Okay, this is the category of one tail on the left. So the rejection region is on the left of your data distribution. Okay. Okay. So you see here, this is the hypothesis testing. Okay, we didn't mention yet about the claim. We just focus on what is the notation for the alternative hypothesis H1. Okay, because the H1 is now the mean is less than a value. Okay, so the region, okay, of H0 is this area on the left side. Okay, so one of the example it can be, okay, the mean, you can write the mean in this form equal 15. Okay, 15 cm. Maybe, the machine on average, the machine that working in one factory on average is less than 15, for example, okay, per week, less than 15. So the claim is actually less than H1. Okay, so the H now is, you can write equal to 15, or you also can write greater than 15. It's much more easier that way lah. Anything that actually greater, you put this way, and then less is on this side. So the separator, this alpha is your significant level. Okay, significant level can be 5%, anything that actually maybe less than 10% lah. The one that's the significant level that you allow certain error. Okay, if your sample is not supporting your claim, okay, it probably fall into this rejection region. Okay, so this is the left tail of your alpha. Okay, moving forward for the second figure, we will see that you look at the alternative hypothesis. Okay, anything that actually involve more than, or another one is actually apa tadi just now, more than, lepas tu satu lagi claim, refer to the table, uh, at, uh, at, at most ke. One at least, at most. Okay, so at most mean is at most. So we use this alternate hypothesis here. Okay, so now the rejection region is on your right. Okay, on your right, and again alpha is your significant level, and that alpha is the critical value. Okay, so these are the second cases of figure. Okay, and the final one is the third figure is when you have a two tail. Okay, um, two tail figure. Okay, where the rejection region have two parts. Okay, But you notice here, okay, the value of significant level, it is actually considered a left tail or right tail test, okay, or the portion of alpha, okay, probability of alpha is on one side, is either on the left or on the right, okay. But when it's involved two tail, okay, the portion of the alpha, the portion of the region has been cut, have been divided into two parts, okay, and where that part is divided equally to the left and also to the right. Okay, so that's why you see here the value of alpha become alpha over 2 on the left and alpha over 2 on the right. And this also gives us the value of z. Okay, this is actually talking about the left side of z. You have negative z alpha. Same goes with this one, negative z alpha. But if you have, if you are talking about the right side of your critical value, okay, your z is actually taking the positive value. Okay, positive value. Okay, so before we move to the next slide, are you can you see the difference between these three, or is there any part that you need further elaboration on the figure? I'm hoping that this figure is able to clearly show you the difference on from the hypothesis statement to the shape of the normal distribution data, and where is actually the location of your rejection region, and what is the critical value implies in your population ni. Saya tak nampak thumbs up banyak sangat. I'm not sure what happened to some of you. Okay lah, baru keluar. Okay, good. So now we are clear about this part. So then we be able to determine the critical value, know the rejection region based on the hypothesis statement from the first step. And then next then barulah, okay, then you come to the final step, you make a decision based on that. Okay, so when we talk about decision on hypothesis testing, okay, there are only two possibilities of decision, guys. It's either we reject H now, okay, or we do not reject H now, meaning that we accept H now. So there are only two possible decision, accept or reject. Okay, we reject H now only if our test statistic sample is actually fall into the rejection region that we talked about earlier in the previous slide. Okay. However, there are also a possible type of error. If you have to be clear here. Type of error here. Okay. We know that we work on the decision based on the sample count, based on the sample that we have. Okay, we do the test statistic, we get the value, and then we compare to the region of our significant level and the error. Okay, the rejection region, and also the rejection region here, the rejection of H null. Okay, whether the test statistic is actually fall into the rejection region, meaning that we reject the H null, or we accept H null. Okay, H null meaning that the claim is not, we cannot say the claim is true. The claim is still depends on what are the initial tests that you do. Okay, so there are this kind of error. Okay, first thing is when we write a statement of H null, okay, and then we do the test, the second step we do the test, and then the value that we get is actually in the region to accept H null, meaning that we made a correct decision. Okay, that is fine. Okay, there are also a certain claim, okay, that we are hoping that the test statistic is actually reject our H null. Okay, so then we also make a correct decision based on the sample. Okay. However, there are also a sample test statistic that we do, okay, where our claim is actually supposed to accept H null, but suddenly your data, your test, your sample is actually giving you to reject your H null. Okay, these are two ways to look on these methods, right? Okay, it probably that the sample that you have is not enough evidence to accept your H null. Okay, and in other situation, okay, your claim is supposed to reject your H null, okay, but then the test statistic that you have is something that actually supposed to be the test statistic is fall into the region where you accept your H null. So then it become also another error. But this error is just probably because maybe your sample of data is not enough evidence to in the situation for you to accept your rationale or to reject your rationale. Okay, we got maybe it's too wordy here, but better way we refer to the example lah. Okay, I think I have elaborate this well just now. Okay, just keep part. Okay. Okay. We are going to see first this. I think this is supposed to be the first one we discuss. Okay. We're going to see this 5 example. Okay. Yes. We have 1, 2, 3, 4, 5. Okay. This step is basically we just want to state the null hypothesis only. We won't solve yet. We won't make any decision on the remaining of the question, but we just want to state the null hypothesis. Okay. Uh, okay, you can refer to this question and try to spend 1 or 2 minutes to come up with the value of with the null hypothesis and hypothesis statement for this 5 example here. Okay, maybe I give one example for this one. Example 1 here. The administrator of the telco service center states that the average waiting time for the customer is 10 minutes. Okay. As a result of complaining, a random sample of 40 customers was selected to collect the waiting time data. This investigation produced a mean waiting time of 11 minutes with standard deviation of 2 minutes. Then you conclude that the average waiting time is more than 10 minutes. Okay. What are the first steps? Okay, when you have this kind of question, okay, so the first step, and 1, okay, write down now. 1, okay, really this one is talking about average, the mean, so the mean the average waiting time is 10 minutes, so this is actually your mean u, the mean, okay, equal to 10, okay, so what are the statement here? It stated average is more than, okay, the claim is actually more than. Okay, so for this example 1, mean is 10 and mean for the H now is mean equal to 10. The H alternate H1 is greater than 10. So this is the first step. Wherever you see any hypothesis testing analysis of data. Okay, just continue with the remaining 1, 2, 3, 4, 5 while I find your student password. You can continue with the remaining of it. Example 1, just come up, just write first the hypothesis statement. Do not solve based on the keyword is actually given here. Oh, example I dengan 1 is already that. Oh, you just mean that you only left 1, 2, 3. Another 3 example. Example 1 is done. I have to change the, make it this example. Okay. Yeah, I change the, I rename the example. Now I put example I 1B is actually the same example. So you can ignore that. Just focus on example 1A and example 2. Write the hypothesis statement. understand why they have the same. One B, one A, and example 2. Oh, sorry, because okay, at the same time, I wish to do okay, you can put in as well your the password for today, for this hour. And at the same time, maybe okay. Are you done? For the third, each of these, on each of these examples, okay, first thing when you are given the statement, okay, try to identify the keyword, okay, that will help you to state the null hypothesis and the alternative hypothesis. Depends on cases, depends on the question, okay, and depends on the cases, depends on your data that you have. Okay. Uh, I just move this one first. So you are done with the state and null hypothesis, alternative hypothesis lah. Okay. The, uh, okay. If you go to for this one, for this slide, for the second one, it is known the average of computer is at least 3.2 hours. So when you are referring to the at least, the statement here is actually at least of 3.2 hours. So the statement, the statement, the hypothesis statement, okay, for this value, okay, is stated that when you have at least of that, so the claim is actually at your alternate hypothesis. Okay, this one, okay, on average is at least 2.2 hours. Okay, and the sample of 30 is just n, and the second is 400 units, and average is 2.3. hours in standard deviation, and we're going to test at alpha 0.1. Okay, for this one, okay, basically, okay, you know that the mean, the sampling mean, one, okay, equal of 3.2. So when it is actually at least, so meaning that at least the claim here is actually 3.2. Okay, so for this at least cases, the claim is at your H now. Okay, this is for the first case. And to move to this one, we won't solve yet. We just want to see the important things about this one. This is another example, okay, where talking about of large city claim. The claim is actually at least 30,000, okay, RM annually. And then this is just they take a random sample of 100 families, and then from just 100 sample, this is the data that they get, okay, and then we have to prove whether the claim is true or not. Okay, so once again, we just write the statement mean equal to 30K, okay, and then the next one is taking the mean, because the keyword here is at least, so we are referring to this hypothesis statement table, okay, at, at least 30,000. So the claim is actually for this H now. So that's why this table is significantly important. So that's what last year, because uh, because we can do this in online. So I think for the test also you I think this is you can start tagging this table, okay, to make yourself familiar. Okay, what would be the form of null and alternate hypothesis statement. Okay, when you found this kind of test or claim in the given cases. But, okay, and let's look at this one. Final example. Okay, this second example is slightly different. Different example. They said that there's a psychologist claim that the mean age at which children start walking is 12.5. Okay. So I want to check if this claim is true. So they took a random sample of 18 children started walking. Was this one from the random sample? They did this and they want to see, they want to try to conclude from using 1% significant level. Okay, if the mean average is different from 12.5 months. Okay, so this one, the keyword here is actually, okay, they want to do some testing to conclude whether the mean age at which all students start working is different from 12.5 months. Okay, so for this one, if you have something that is different from or not equal to, so your mean for the HNL is equal to 12.5. Okay, this is the claim. And this is the claim is actually asking stated that different from 12.5. So the claim is actually at the alternate hypothesis claim. Okay, so this is the statement, hypothesis statement for this case. Okay, we haven't solved yet. We haven't go through the 4 steps yet. We just this is just an overview first about what is the hypothesis statement, where to spot the keyword, okay, that help us to determine to write to state the hypothesis statement. We haven't solved yet, guys. This is just okay. So far, do you think that you get some idea on how to write this the state of hypothesis statement? Okay. Do you think any challenge here? Again, basically I try to guide you first. Okay, what are the keywords that you should look for when they are asking you to write the null or alternative hypothesis? Okay, and at least which slide you can refer first to for this for the first for the first second week, okay, to make yourself familiar on how to write the proper hypothesis statement. Okay. Okay, so we are done with this one. Okay, so let's recall back. There are 5 steps. Okay, there are 5 steps or 5 or 4 steps in general, okay, to perform a hypothesis testing. Okay, we we get some idea. Okay, at least we know we already get some idea on how to write the null and alternative hypothesis. Okay, at least you know which slide you should refer to, and what keyword that you should pay attention to when you want to state the null and alternative hypothesis. Okay. Next step is you will choose the fixed significant level alpha in your cases. Okay, because this alpha will determine why this alpha is very important, why this significant level is very important. Let's come back to this figure, this 3 figure, because it will help you to determine the rejection region. Okay, whether you are focusing on the left tail test, okay, or the right tail test, or the 2 tail test where the significant level have to divide by 2 to give you on the rejection region on the left and also on rejection region on the right. Okay, so this is another step, okay, which is very crucial when you want to perform the hypothesis testing. You have to choose the significant level, okay, and this will is actually depend on the correct null or alternative hypothesis that you established earlier. Okay. Next is for you to choose the appropriate test statistic. Once again, this one there are only 2 types of test statistics, okay, which actually can be split into 4 different conditions, okay, which is actually depends on the number of sample size and also what else? Number of sample size and also whether the variance is given or not given, known or unknown. So that the table with 4 column, okay, where the 2 main column is to split between the large and the small sample size. Okay, so you should refer to that. And then you will establish the critical region. Okay, well, still come back to this one. Okay, whether this is the critical value that you should refer to based on the significant level alpha that you get from the second step. Okay, so whatever this value is being the critical value, and then you have your test statistic. Okay, you will see that test statistic is actually appear on which region, the rejection region or the non-rejection region. Then you make a decision. Come back to this. Okay. Any questions so far? Already 9:70. Maybe we will try to discuss 1 or 2 example before we end this session first. And then later, I believe you can explore more. Okay, so let's. I'm going to use this one as example. Okay, so for this one, okay, so we already state first we do the first part, state the null and try to find the keyword, the important keyword that will help us to write the correct hypothesis statement. And then after that, you choose the significant level alpha. So here, directly it is actually given. Okay, we have to check whether our claim here is true. Claim here is actually stated that at least 30,000 of this family. The mayor of the large claim that the average net worth of the family living in the city is at least 30,000 annually. Okay, So we want to check whether the claim here by this mayor is true, okay, that by this politician is true. So we are using the 2.5% significant level, okay, 2.5% significant level. So I just maybe use this one. Normally I would write, but because already done that. Okay. So first thing first, you refer to this one, try to write down all the important keywords. Okay. So this is from the statement here, at least we come out the first step. Okay, write the statement, the hypothesis statement. Okay, what is the second step? Choose the significant level. So this is your alpha. Okay, alpha 2.5, or in the value is 0.012, 0.025 is your alpha. Okay, so your alpha, the critical value, your significant level is 0.05. We were going to use this to get our critical value, meaning that, okay, so from of this, okay, if we have less than, for this one, is it one tail or two tail test? If you want to choose an appropriate test statistic here, are we going to use one tail test or two tail test? Based on the statement, hypothesis statement here. So this is the second step. The third step is to choose the appropriate test statistic. Okay, there are three possible test statistics. One tail, two tail, left tail, right tail, or two tail test. You can unmute your mic or write your answer. For this example, 1A.
Left tail. One tail.
Left tail. Left tail. So how we know that? Based on this. Okay, thank you. Okay. So left tail. Okay, so left tail we actually expected. Okay, the rejection region is on the left. Okay, and we're going to find what is the Z alpha here, the critical value here. Okay, that will be the choose the test, appropriate test based on the state of alternate hypothesis that we obtained in the first step. We are done here, we know we already choose here. Okay, next is we're going to establish the critical region based on the alpha that we have. This is actually coming back to the Z value that Z test value that we obtained. Okay, in the third step here, before we decide which whether it's actually fall into the rejection region or it's actually on the or non-rejection region. Okay, meaning that we accept this is the place. Okay, so this is the place where we accept our H null. Okay, and this is the place where we reject our H null. Okay, meaning that it's actually H1. We allow certain we still allow certain error in our claim. Okay. What else? Establish this one, and then we make the decision whether we reject or accept. Okay. I already have this solution here, and return solution. Going to use that for this session. Okay. So this one step one clear, everyone. So we state the claim where it's based on the given question. Next is we do the Z test. Okay, the Z test is this is exactly the Z test if you refer to the table that consists of 4 tests. 4 different tests depends on number of sample. Okay, so for this case, the number of sample is 100. So it's considered a large number of sample. And based on this, the variance is unknown. Okay, the variance of population is unknown. So we use the sample variance. So it gives us the sample standard deviation, this S. Okay, let's turn back to this. Okay, so we are taking this n number of sample, and from this number sample, it gives us the mean of the sample x bar 28,800. Okay, and also the standard deviation of the sample from the sample, meaning that we have S, okay, which is 8,000. So we use this data, okay, to establish our Z test. Okay, to establish our Z test, and then we already know by now is actually we are talking about the one tail, which side, the left side of the tail test. Okay, meaning that the rejection region here, using the significant level alpha 0.025. Okay, and we can determine the critical value, the Z value is supposed to be negative value. Okay, how to determine this 0.025? We are referring to the normal distribution table. Okay, normal distribution table, you can either use Excel or you can use the conventional way where you refer to the table of normal distribution. Okay. Yeah. Okay, so where is this 1.96 coming from? So we zoom in into the inner side of this table, looking for 0.025, 1025. So here, so 0.025 is negative, is in the row of negative 1.96. Okay, negative 1.96. Okay, so you get that value. So that will be your critical value that separate between the rejection region, the yellow area here, and the accepted region. Okay, so this is the critical value, negative 1.96. Based on your Z test, the one that you did, okay, you get negative 1.5. So negative 1.5 is somewhere on the right side of your region or of your data. Okay, based on the sample size, the Z test here, okay, this Z test, okay, negative 1.5 is in this on the right side because the separator is at negative 1.96 based on the critical value. Okay, so the critical value is based on your significant level. Okay, so negative 1.96 is this area, but based on the sample that you get, Z test value is on the negative 1.5, which is actually on the region where you accept your rationale. Okay, so because of that, because of the condition of the Z test is on the right side of the critical value, okay, so it's actually in the non-rejection region. So when it's actually non-rejection region, in that you accept your rationale. So your final way on writing the decision, we can say that, so the average net worth of the family living in this city is at least RM 30,000. Basically, you just rewrite back the first claim when the claim is true. Because the data, the sample data that you have is supporting the claim, where it gives you the, is on the right side of your from in this region lah, H0 region. So can you get the step by step for this example? How we can write in the step 1, 2, 3, 4, 5 before we come out with the final decision. After meaning that after you have a point whether you accept or reject your rationale, the final decision you have to write some remark there to support what is actually the claim that you made earlier, the average net worth of family. So basically you just take back the sentence that initially, if this is the claim that you make, if the sample data is really supporting your claim. Anyone want me to repeat this part? Any part of that is not clear? So this step by step is very crucial when you want to do any reporting on based on the sampling data that you have. I know this is just a very straightforward example, but later on when you apply for different cases, or maybe later in your FYP or IDP, okay, maybe you have some raw data and then you want to make some analysis of it. So these are the steps, these are the procedure that at least should be captured in your reporting, in your final reporting of your product. Is it okay we look another example before we end this session?
Okay.
To enhance our understanding on this. Okay. So this is the second example. Okay, so now there's a psychologist claim that mean average at which students start working is 12.5 months. Okay, and then suddenly this girl I want to check if this claim is true. So she pun took a random sample from 18 children, and then that will start working 12.5. Then from that 18 children sample, Ain find out that these children will start working 12.9 months. Okay, and then on average 12.9 months, and the standard deviation based on this 18 sample is 0.8. Okay, so using because she want to check whether the claim is true, she using 1% significant level. Okay, so let's try to help Ain to conclude whether the mean age at which all students start working is different from 12.5 months, as what this psychologist claimed earlier. Okay, so here they just assume that the age at which all students start working have an approximately normal distribution. Okay, once again, we just follow all the 5 steps. Okay, we already get the first claim, the first hypothesis statement. Okay, we already established that. Okay, clearly we find that the number of sample is a bit small here. Okay, we have to check whether the variance is given or not given, known or unknown. What do you think about this one? Is it known or unknown variance for this example? Is the variance is known or unknown for this example too?
known.
Betul ke? Known. Variance of population. Sorry, I read that. I think variance of sample is given, but the variance of population is unknown kan?
Unknown.
Okay, I put tadi salah. Okay, so since the variance is unknown, this sample size is, okay, thank you Ashraf. Okay, is also is a small sample size. So we know that we can refer to P distribution here. Just to double check whether this is true. Okay, if the small sample less than 30 is small sample. Okay, if the variant is unknown, so we know that we are refer to the T distribution. So this is how this table is helping us to determine what kind of test, what kind of critical value, and which type of table should we refer to when we want to establish the critical value. Okay, so we do that. Then let's have Ain here to check to conclude whether this psychologist claim is true or not. So come up with this solution. 1, 2, 3, 5 steps. So the first step, clear where the claim is. Okay, try to establish the claim. So we are doing based on the sample test, the data that Ain have. Okay, and then we get the test value, which 2.1213. Okay, because we are using the sample standard deviation, the sample mean. Okay, and then because of the test, because of this is actually the hypothesis statement is involved differ or exactly true. So these are the example where we are referring to the two tests, the two-tailed test. Okay, so we have two sides of region where it appear to be a non-rejection region. Rejection region, okay, two side of rejection region. So from this, from the test statistic, we get this value 2.1213 test statistic of the sample. Okay, the critical value is based on the T distribution. Okay, T distribution where the alpha for this case, what is the value of the alpha? Just 0.01. Okay, so for this we want to help Ain to determine based on the significant level 1%. Okay, so it becomes 0.01. Okay, but because of T, okay, the T distribution, the alpha have to divide by 2 because it involves very small data. Okay, so alpha divided by 2, that's why you get alpha 0.005. Okay, and then n number of sample is 18, but because we are referring to the T distribution table, so n minus 1, it becomes 17. So T 0.005, 17, refer to the table. Okay, let's refer to the table. Which table? Table of T distribution table, 0.05, which means 0, double 0 and 5 on the fifth column. and then go to the row 17. So it gives you 2.898. Okay, so what is this 2.898 means? It is a separation data, okay, the critical value that separate between the rejection region and non-rejection region. Okay, so that's why, because this is involve two tail test based on the segment, hypothesis segment. So that's why we have the left and the right. So anything on the left you put negative of the critical value, and anything on the right is giving you the positive value. Okay, positive value. So you have two sides of it, but based on the data, 2.1213 is actually somewhere in the between. Okay, so the test statistic based on the sample that you have is actually in supporting on the accept your H now. Okay, because your T test is basically in between of your critical value. So you actually in the accept H now condition. Okay, so from this, since we accept H now, so what is the decision, the final decision that you have to write here? You will say that yes, the mean age at which all children will start working is 12.5 months, meaning that here for this case, the sample that you have also support your claim. Okay, can you see the difference between the previous example and this one? Any part that that you need further elaboration?
Step 5, Doctor.
Okay, step 5. Okay, once you say you accept H now, okay, you have to come back to what is the H now that you have here. So H now here is actually equal to 12.5. So when you accept H now, you just write back, okay, you just write back that the H now is the mean, just write back this one. So meaning that the mean age at which children start working is 12.5 months. Even though the claim initially wants you to test whether the children start working is different from. Okay, the claim is here different from, but because from the sample test that you do, the data is showing that it's actually to accept your HNL. So you have to refer back to the statement of your HNL. You stated that the mean age at which children start working is 12.5 months. Basically, you just state back what is the HNL statement. Okay. Always come back to this one, right? Okay. The purpose of doing hypothesis testing is whether we are accept H null or reject H null. Okay. So you whatever it is, okay, you have to go to until the step 4, whether your data, your sample data is really supporting your claim, or actually whether to accept your H null. Okay, if it's actually supporting your claim, probably because your claim is actually H null at the H null. Okay, or or maybe your data is actually accept your H null. Okay, accept H null, meaning that your claim is not true. So you can say that the mean you can always say that I think I have to put this here. Okay. In some cases the data, the sample that you have is correct to support your H null. You need that as a H null. Okay. In some cases, the sample that you get is probably leads you to reject your H null. Okay. So but in the rejection region, okay, of the H null, meaning that to reject hash null, obviously your sample data must be in the rejection region lah. Okay, in the rejection region. So the error here meaning that it probably because the sample data that you have is not enough evidence to really accept your hash null to make it your hash null is true. Okay, so this kind of error don't panic. It's not every time you get a rejection of hash null is a bad thing. It could be because of your sample data is not sufficient, not enough to support the acceptance of your hash null to be in the acceptance region. Because you have to be mindful now, be aware that the hash null statement is the one that you set based on the first claim. Okay, and then you have the second step where you have to find the value, the test statistic based on the sample that you have. In some cases, maybe the sample is really support the acceptance of your hash null. Okay, but there are also some cases that maybe your sample data is not didn't have enough evidence to accept your hash null. So it's not the error here meaning that it could be because the sample data is too small, or maybe your significant level is too big, and that leads to have and that is actually why your test statistic is fall into the rejection region. So there are many ways, there are many possible cases that can fall into any of these four categories. Okay, so we will look more different example later during the tutorial class next week. Okay. We're going to look more different cases. So and hoping that you get more confident when you are dealing with this hypothesis testing topic here. Okay. Okay. So just recap lah what we have seen for today's session. So but at least I'm hoping that for now after you complete listen to this session, now at least you get some idea what is actually the concept of hypothesis testing. Okay. At least for now, for today we just discuss about on how to identify the test for the mean, sampling mean. But as usual, if you understand the procedure on identify the test for the mean, you definitely can expand it into the proportion, sampling proportion. Okay, and then but at least for now until at the end of this session, you already get some idea on how to apply this hypothesis testing method before you make a decision making in helping you to establish the claim. Okay, at least the two example maybe it's not sufficient yet, but I'm hoping that you get some direction where to refer to when we are talking about hypothesis testing. What are the steps that involved in this hypothesis testing? So basically, we have covered this. Maybe on our next class next week, we're going to complete the remaining part. But at least I'm hoping that you make yourself familiar with this table and how this table is helping you to determine what kind of test that you should refer to when you want to do the hypothesis testing analysis. Okay, so far this is what we learned. It's quite a lot for today, for almost 2 hours. But we will start with simple case, one population first. Make yourself confident on all the term, all the procedure. If you have a problem, you can always discuss during our tutorial class or maybe after this session. So just DM me. So maybe I just show you in. So basically in the test, because you are doing it online, maybe you can start prepare this slide, you can start print this and have a copy somewhere in your in your space for study. this key formula. Even the formula is given, guys. So your role is actually know what is actually the meaning, uh, 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 how to use this. Okay, clearly, this number 2 is for you to determine the confidence interval. Okay, you have 1, 2, 3, 4. So this 4 is for 4 different kind of sample size, and also whether the variance is known or unknown. Kan? And for number 3 is to the kind of test statistic that you need to do. Okay, this one is when the test is for the normal distribution, when you transform from to get the Z value, normal distribution. This one is when the variance is unknown. So you use the standard deviation from the sample and also the mean from the sample. So this is for sampling mean. Okay, and this is the value when you want to find the sampling proportion. Okay, so the key formula is given, is already there. Your role is actually to understand how and when you we should refer to this formula. Okay, I think that's all for today. If you don't have any questions, and if you already signed your attendance, we can end this session now. So thank you, everyone. Any question? If no, so we can end this session. So I will stop. I will stop recording.
Doktor, password yang tu